Hello, everyone. I would love to discuss continuity and differentiability. So we want to determine if differentiability implies continuity and if continuity implies differentiability. So let's look at the first statement. If f of x is differentiable at a, then f of x is continuous at a. So f of x being differentiable basically means that the derivative of x exists. So if f of x is differentiable at a, this means that the derivative of x exists at x equals a. So what does it mean for a function to be continuous? It basically means that we can draw the function without picking up our pencil, or we can understand it in two ways. We can draw it without picking up our pencil, or we can approach a point on the function from both the left-hand side and the right-hand side, and we can poke at it with our pencil. And they all equal the same value. So let's look at these examples of f of x equals x squared. So this function, x squared, does have a derivative by the power rule. So because the derivative 2x doesn't have any holes or asymptotes or any outstanding features, we can say that this exists for all x. So the derivative exists for all x. So this means every single one of these functions or every single one of these points has a tangent line. Now, if you have a tangent line, this means that the point or that point with the tangent line has to exist because how it has to hit the point on the graph. The tangent line has to hit the point on the graph, and the point on the graph has to hit the tangent line. So there has to be a point on this graph. So since every single one of these points exists, and every single one of these points has a tangent line, differentiability doesn't imply continuity because every single one of these points has to be continuous. Now, if f of x is continuous, does this imply that f of x is differentiable? So if we look at this counterexample with the absolute value of x, it can be characterized as this piecewise function. So this piecewise function, if we understand it, we just say that if x is greater than 0, it's this function. If x is less than 0, it's this function. And if x is 0, then it equals this. So we can see that this point is a corner. It's characterized as a corner. And corners do not have derivatives. So despite me being able to draw this without lifting up my hand, despite it being continuous, it doesn't have a derivative at every single x. So if we put it from the left-hand side or the right-hand side, it'll equal different numbers, and it's undefined at that point. So despite the function f of x being continuous, it's not necessarily differentiable. But if a function is differentiable, then a function is continuous, because if a function is differentiable, every single one of these points has a tangent line. So every single one of these points has to have a point that is continuous. Therefore, every single point is continuous. So f of x is continuous.